Good morning everyone. My name is Ashish Gore and this is my ADA assignment, final paper, internal, final paper exams. First question is, analysis the time complexity of the quick sort algorithm in average case and provide step-by-step explanation. And the solution is, quick sort is a popular sorting algorithm that employs to divide and conquer strategies short an array in place. It is an average time complexity of big O of n log n, and the worst case time complexity is big O of n square, where is the number of element in the array. Here is a step-by-step explanation how the quicksort algorithm works. First, choose a pivot element from the array. The choice of the pivot element can be vary, but one common strategy is to choose the large element in the array. Step second, partition the array into two subarrays. Only subarrays contain the element smaller than the pivot, and the subarray contains the element greater than the pivot. This step can be performed in the variety of the ways, but one common strategy is to use two pointers I and j that start at the opposite end and array and move toward each other when I and j meet all the elements to the left and I are smaller than the pivot, and all the element of the right I is greater than the equals to the pivot. Third step, recursively sort the subarray. Apply the quicksort algorithm to subarray contained element smaller than the pivot, and the subarray contains element greater than the equal to the pivot. Com- Combine the shortest of the array since the subarray are already sorted. Then the step travel simply contain the subarray in the order of subarray element smaller than the pivot subarray is the element greater than equals to a pivot. In average case, the time complexity of quicksort array using the recursion, let t of s be the time taken to sort the array and the element using the quicksort. The recursion relation are t of n equals to 2 t of n by 2 plus O of n. The first term right hand side outside corresponding the time is taken to the short two subarrays, each of the size n by 2. The second term corresponding to the time it takes to the partition the array, which is linear in the size of the array. Using the master theorem, we can solve the recursion relation and obtain the time complexity for quicksort average case. T of n is equal to big O, and therefore the average case quicksort complexity of big O of n log n, which is faster than the other sorting algorithm. However, it is important to note that the worst time complexity of the quicksort is order of n of 2, which occurs if the pivot element is always chosen larger than the element array. To avoid the worst sort category, modify the quicksort algorithm and been proposed by choose a pivot element. Second question is, critically evaluate Self metric multiplication and compare its time complexity with the traditional multiplication method. Since Sten's algorithm is divide and conquer algorithm used to metric multiplication, the algorithm is named after the Walker Sten's, who introduced in 1969. The algorithm is known as for its efficiency and dealing with the large matrix. The traditional matrix multiplication method has a time complexity of O to the n cubed. The algorithm required their nested loop to compute each entry of the resulting matrix in contained Sten's algorithm has a time complexity of big O of n to the power log 7, which is approximate big O of n to the power 2.81. Sten's algorithm is faster than the traditional algorithm for larger matrix if when n is greater than 100. The main idea behind the Sten's algorithm is divided into a matrix into a sub matrix and recursively compute the product of this sub matrix. The algorithm uses 7 multiplication instead of usual 8 multiplication required for matrix multiplication. The 7 multiplication are combined in the specific way to compute the final product. However, strength algorithm has some disadvantage. Firstly, the constant factor in the algorithm are relatively high. Secondly, the algorithm only works efficiently if of this size and the other power of 2. For the matrix of the size algorithm can be extended by adding the matrix with zero to a size that is the power of 2. In summary, strength algorithm is efficiently algorithm for the matrix multiplication for the larger matrices, but it is some limitations such as higher constant factor and the restriction on the input matrix size. The third question is evaluate Bayes algorithm for the finding the minimum spanning tree and provide a real world scenario where it can be applied. Bayes algorithm is popular algorithm used to find the minimum spanning tree of the graph. The algorithm starts with a single vertex and grows the tree by the representing adding the cheapest edge of the constant and the tree of the alternate vertex. The process of continues until all the vertices are included in the rated time. The time complexity of the Bayes algorithm order of E log V where E is the number of the edge and V is the number of the vertices in the graph. The space complexity of order of V plus E. Bayes algorithm can be applied in various real world scenarios where we need to find the minimum cost network such as communication network. In a communication network we need to find the minimum cost of conversion between various communication nodes such as routers and servers. Routers and servers. Bayes algorithm can be used to find the minimum cost connected and create the efficient network. Transition network. It is a transition network. We need to find the minimum cost path between various locations such as citizen ports and airports. Bayes algorithm can be used to find the minimum cost path and create a efficient translation network. Power network. In the power network, we need to find the minimum cost connections between various power stations, transforms, and distribution content. Bayes algorithm can be used to find minimum cost connection and to create efficient power network. Overall, Bayes algorithm used to tool to find minimum cost network real world scenario. Fourth question is analyze Hamilton cycle and provide a case where it can be applied in the real world scenario. Hamilton cycle is well known problem in the graph through the inner finding the cycle passes through all the vehicles of a graph exactly once. The problem in the NP compute meaning that it is known to be have an efficient algorithm to solve it. Worst case scenario deposit its complexity. It is the Hamilton cycle program have many practical applications. When the such application is field integrated uh, circuit design in the context can be modeled. The graph will be various responding in the individual component and the edges responsible for the connection between them. Finding a Hamilton cycle in the graph would corresponding to the finding the path of the passes and the corresponding of the circuit exactly once. This can be used to optimize the design and the assurance that all the components are used efficiently. Another real world scenario where the Hamilton cycle problem is applied in the field is of logistics and transportation. In this concept, the vertices of the graph represent citizen of the location and the each represent the distance between them. Finding a Hamilton cycle in this graph would corresponding to find a route that visit all the cities exactly once when useful optimize the delivery route and the planning of the route. Fifth question is drive the time complexity of the iterative and recursive version of the Fibonacci series. The time complexity iterative of the recursive function of the Fibonacci sequence algorithm to find can be derived as follows. Iterative Fibonacci The iterative Fibonacci algorithm uses a loop to iterate over the element of the sequence, the compute the next element based on the various two elements. The n complexity of this site can be Geneva contain the number of the opportunity required to compute the nth element of the sequence. The algorithm performs one additional operation in the element sequence so that the total number of the operation can be expressed as the sum of the first and the Fibonacci number use of the formula for the sum of the Fibonacci sequence we get. Sum of the first and Fibonacci numbers f of n plus 2 minus 1. Therefore, the time complexity of the iterative Fibonacci algorithm in the f of n, where f of n is the nth Fibonacci number, recursive Fibonacci. The recursive Fibonacci algorithm is used the Fibonacci algorithm is used to recursive to compute the nth element of the sequence based on the previous two elements. The time complexity of the algorithm can be divided by the containing the number of the recursive calls that are made to compute the nth element. Each call of the Fibonacci function results into the recursive calls. Two recursive calls Fibonacci each is the result of the recursive calls compute the previous two elements of the sequence. Therefore, the total number of the function call can be expressed as the n minus 1 Fibonacci number. Useful formula for the Fibonacci sequence we need to uh, f of n plus 1 1 divided by square of 5 is a 1 plus multiplied by 1 plus square of 5 divided by 2 to the power n plus 1 minus 1 of the square root of 5 divided by 2 to the power n plus 1. Therefore, the time complexity of the recursive Fibonacci algorithm of f of n, where f of n is the nth Fibonacci number. Note the recursive Fibonacci algorithm for explaining the computing makes efficient version. Here is the sixth question of the question paper. Explain chain matrix multiplication and deliver its time complexity. Chain matrix multiplication is the problem which is when given to sequence of the matrix to multiply, and we need to find the optimal order of the multiplication that minimize the number of the scalar multiplication. For example, given matrix A B C D, we can choose the multiplication then in the order of A B C D or A B C or D. The former requires two scalar multiplication while the latter requires three. To solve the problem, we can use dynamic problem. We first define a cost function m of ij and the representing the minimum number of the scalar multiplication required to compute compute the product of the matrix ai plus aj until aj. The solution of the problem of the m of 1 of n where n is the number of the matrix. The cost function can be divided recursively as follows: m of ij who is I is equal to j, m of ij equals to minimum m of ik plus m of k plus I comma j plus phi of minus 1 pk p I is less than equals to k less than equals to j, where I phi minus ip kj represent the cost of the multiplication matrix of ai plus a to ap and ap1 ap plus 2 or to a. We can use the bottom row to find the cost table and the time complexity of the algorithm. Algorithm order of n in the therefore the that's it. Thank you.